This is Mr. Ring going over your Math 5 quiz number 6 on 1.31 to 1.34, taken November 22nd, 2019. Multiple choice directions, circle the best answer. Question number 1, the graph of y equals x squared is shifted up 9 units and to the left 1. Write the resulting function. So these are transformations. X squared looks something like this. And then if it's shifted up 9 units, then your graph's going to move something up here. And then if it's to the left 1, it's going to go in this direction. And if you do your transformations, y equals a times f of b to the x minus c plus d, the left one is here, and your d value is there. So in your transformation, it would probably look something like this. The graph has not been flipped over the x-axis, so a is equal to 1, which I don't need. That's your function, whatever it is. B value is a horizontal compression and stretch, which we don't have. And pay attention, here, your c value is -1. And your d value there is 9. So if I put those in, I get x. Remember, the formula has to have that minus sign. That's why it's outside of the pink here. So -1, and then going up is +9. So if you clean that up, you'll have something like this. X plus 1 plus 9, and then this was a power of 2. So you'll have something like this. So this is vertex form, and then this choice would be letter choice D. Question number 2. In question number 2, you're given, it says identify the end behavior of the polynomial function. So end behavior, you really think about it, is just those arrows. Where are those arrows? Let's see what kind of hints they give us. F of x equals x cubed minus 3x minus 2. So you have a polynomial. As a review, if I put my finger over all this stuff, this would be called a power function. What's the difference between a power function and a polynomial? You just have other stuff that can kind of give you hints. This one is just at the origin. So here are some hints. This is an odd degree, and the easiest one you know is x to the first, and that would be starting down, ending up. And also the leading coefficient, is it positive or negative? Well, it's positive because there's no negative, which means it stays on these arrows, right? Okay. So this gives us a hint. Now, if you think about the x-axis here, highlight that in yellow, that's really all the first component of this part right here. And that's essentially just going either left or right. What's happening as you go left or right. And then let's see if I have another color. The y-axis is what's happening over here. Sometimes they call that the f of x. In this case, they had a y. And in blue, that's just figuring out if it goes up or down. And if you need help, you can write the negatives on the x-axis, negative numbers, positive numbers over here, negative numbers, you can see -5, positive numbers. So this one says, as x approaches negative infinity, as x goes to the left, what's happening to our graph? Our graph should be going, on the blue, is going down. So down is the blue box, and that would be negative infinity. So I really want to see that say negative infinity. This is saying as you go to the left, the graph goes up, which would be incorrect for this problem. So let's find one that has negative, negative. There it is. As x approaches negative infinity, as your graph roller coaster goes towards the left, what happens to the graph? It goes down. That one works. This one didn't work. As the graph goes towards the right, as the x goes positive infinity, what's happening to on your roller coaster? The roller coaster is going up. Up. Y approaches positive infinity. So your letter choice is going to be C. C is your correct answer. Let's show why the rest of these are wrong. As x approaches towards the right, the graph is going up. So that one's correct. As the graph goes towards the left, this is saying the graph is going up. That's wrong. As you go towards the right, it's going down. That would be totally wrong. Graph goes towards the left, goes down. Correct. And as x approaches infinity, to the right, it goes down. That's wrong. So C is your correct answer. Question number 3. Identify whether the polynomial function graphed has an odd or even degree and a positive or negative leading coefficient. So we got to figure this out, right? Okay, let's figure this out. All right, even degrees, we just did one above, is going to start up, end up. So my arrows are not in the same place, so this is not an even degree. I know it's going to be an odd degree. So easiest odd degree we know. This was x to the second. X to the first is the easiest one we know. It starts down, ends up. Looks like that on the coordinate plane, right? A linear equation. Now, they're in opposite directions, which matches ours. But if I do negative x to the first, it would look like this. So I know that it is a odd degree polynomial, and it has a negative leading coefficient. The reason why it's negative is because it basically flips it over the x-axis and looks like this. You see how ours match? Starts up, ends down. So I'm going to look for an odd and negative. Odd and negative, there it is. A is your correct answer. Let's try number 4. Determine algebraically whether the function is even, odd, or neither. Okay, that was the algebraically was that star problem. Remember we always talked about that? Sub negative x for every x. If it's equal to the original function, then it is even. If it is the opposite, opposite of the original function, then it's odd, and then it's neither. If it's not even, not odd. So let's put in negative x for every x value. Let's do that right there. So I'm putting into this function negative x, negative 3 times negative x to the 4th power times negative x squared. To simplify, I'm going to use the order of operations. So this basically means there's 4 of them. Again, you don't have to write this out if you already know what the answer is, but it gives you an idea. and this one has 2 of them. So this would equal a positive and positive. Positive times a positive is a positive. Positive times the negative is negative. X times x times x times x. Multiplying the same base, you add the exponents. So you have negative 3x to the 4th power there. And then this one is negative times negative is positive. Positive times negative is negative. X times x is x squared. So if you look at the problem, this is the original problem. And a lot of students get confused on the next step, so I'll just explain it. So every time I see negative 3x to the 4th minus x squared, I can write f of x. See this, write that. This is proving it's the original problem, so the answer is even in this one. Now, the big idea for determining, this is called a symmetry problem. And this one is a degree problem, okay? Totally different. Why? Because even though they have the same words, even and odd, they're 2 different concepts. This one is talking about where is it reflected over. So if you do yourself a graph, you'll realize that this graph is to the 4th, so it's an even, but it's pointing down. Probably looks something like this, a W. You can even get way better if you factored out a negative x squared. Let's see what happens. It basically says I'm going to go through the origin, right? You could set it equal to 0. X is equal to 0. It is it has a even, so multiplicity is even, so it's going to be a kiss at the origin. And then if you do this one, it'll be a imaginary. So let's double check that. So in this problem, it kind of just looks like a, oh, what happened? I think we have some multiple graphs in there. I want to see what's below there, the y. So negative 50, count by tens, so it happens. So it looks kind of like a power function centered around the origin. And this problem, like we said, is talking about its symmetry. Even symmetry is evenly folded about the y-axis. So this is algebraically. I'm trying to show that to you graphically. All right, last question. Multiple choice. Graph the function x plus 2 squared equals, or times x minus 3 cubed. And what this problem is a multiplicity problem. And what we did is if you set each of those equal to 0. Now I want to make sure I understand what, there's 3 of these. There's quantity 3, right? I'm recording this on Black Friday, so if I order something online, there's quantity 3 of those. Okay, so if I don't need to do each one of these because it's repeated, so I just do x plus 2 equals 0. And if I subtract 2, you now have they call this a 0. Binomial is the same thing as this 0. Parentheses x plus 2, this binomial is the same thing as x equals negative 2. And if we do the same thing over here, you add 3 and you get x equals positive 3. What I'm trying to say is you don't have to do this problem right here. You could do it again, you'll get x equals negative 2. And you could do this 2 more times. And so a lot of times what they do is sometimes you'll see the word multiplicity of 3, multiplicity of 2, which we've talked about in class. And so you can make a chart. I like to make this little chart here. You don't have to, but it helps. I have the zeros, x equals -2, and x equals 3. I'm going to talk about its multiplicity. So multiplicity again is, let's make this clear. Multiplicity is the number up there. Do you see how it matches? So x equals -2. This is all this work over here. It has a multiplicity of 2. And this one has a multiplicity of 3. Shoot through or kiss? Well, evens. This is an even number. You're going to kiss. And then this one, you're going to shoot through. Now let's figure out some other clues that might help us. The degree of the polynomial. You could multiply all these out with multiple boxes, but not helpful. So x squared. Here's your not trick, but shortcut or something faster. X to the third. Same base, you add the exponents, not multiply. So this is x to the 5th. This is an odd degree polynomial. And if you look at it, we actually have 2 odd degree polynomials. It's just multiple choices, just either A or B. The leading coefficient here is positive because there's no negative there, so they will stay in those locations. So let's look at our zeros here. At -2, we expect to have a kiss. Kiss bounces off. This one shoots through, so that's wrong. I already know this is wrong. But let's go through the other clues. Might be super helpful. X equals 3. You expect a shoot through. And there's a shoot through. Now that one's wrong. Okay. Let me show you one more. We kind of did this in class. If you multiply all of the last numbers, again, we're not trying to multiply all this out, but might give us a super good hint here. 2 times 2 is 4. 4 times -3 is -12. -12 times -3 is 36. And 36 times a -3 gives me -108. And if you look at that, when you multiply all those numbers, I get -108. There's the y-intercept. See, it was supposed to be down here. So a bunch of clues to show us that the answer is A. A is the correct answer for question number 5. So 5 multiple choice questions. Gives you 10 points for multiple choice. Again, we're not going to mark that. We're marking on the Google form. And then you'll get out of 10, and then the name and period. Let's turn the paper over and look at the free response. All right, backside, make sure to show all your work and box your answers. Here it is, guys. Keyword right here. Sketch a set. And I took this problem directly from one of your skills practice or problems in class. Sketch a set of functions whose product is a cubic. Okay, we need to make a cubic function with the given characteristics. Explain your reasoning. Extra credit if you can write an equation for each. Okay, so how do I form a cubic? So let's color code that. X equals -4. X equals 2. And then x equals 3. So you can do 3 linears would work. So this would give you full credit. A linear times linear times linear equals, this is my explaining part, equals cubic. Okay, we said that you can get extra credit if you can make a equation. So if you go -4, the easiest one is to go to +4. And then if you draw a line, let me see if we can find something with a straight edge around here. Old credit card. So that pink one. This would be a y-intercept at positive 4, so y equals x plus 4. Slope of rise of 4, run of 4 gives you 4 over 4, which is 1. Maybe do the same thing here at 2, negative 2. That would be y equals, again, yours is going to be all different. And then if you did it at 3, you go to 3, so your y-intercept, that's minus 2. Minus. Let's try that again, x minus 2. X minus 3. So linear times a linear times a linear equals a cubic. Now, you can also have done something like a linear times a quadratic equals cubic, right? X to the first times x to the first times x to the first equals x to the third, or x to the first times x to the second equals x to the third. Also, you can have had if there's 3 zeros, then you will have a third degree polynomial. And we know a third degree polynomial is cubic. Okay, so let's talk about some common mistakes. If you watched last year's video, you would have seen that. They draw cubic. Draws cubic. They would have done something like this. Based on those pink, yellow, and blue, they would have done something like that. This is a common mistake, CM. And they forget to read the word set. So I'm not asking you to draw a cubic function, I'm asking you to draw a set that makes that, right? So how did I give you some points here? Looking at my last year's notes. Okay. You get 2 points if you just draw a cubic function, the common mistake. Of course, you get all correct with an explanation. Let's just say you draw something that's all correct, no explanation. Or vice versa, you have an explanation, graph wrong. And then I'll give partial if like you missed one or something. All right. Number 7, fill in the blank square so that each row and each column contain all the digits 1 through 4. Numbers and cages may repeat as long as they are not in the same row or column. So the darkened ones are a cage. So I need 3 numbers that multiply to be 24, 3 to multiply to be 2, 3 to multiply to be 6, 3 to multiply to be 8, and 4 numbers to multiply to be 24. Definitely use a pencil. All right, so my strategy is I can only use the numbers 1, 2, 3, and 4. I like to write that down, super helpful for me. And 3 numbers that multiply to be 2. Well, I'm thinking of 1 times 2 times 1. And in the corner problems where you have to repeat a number, put those apart because they're not repeating in a row or a column. So I'm missing the numbers 3 and 4. So if I do 3 and 4, watch this. 3 times 4 is 12. 12 times something equals 24. That's going to be 2. Now, I'm not quite sure if the 4 and 3 are in the correct order, so I can just keep going and then see what happens. 2 numbers that multiply to be 8. Okay, so I can choose 2 times 2 times 2, but those would be repeating numbers. So I'm thinking of 1 times 2 times 4. Now, if I put the 4, I could put the 4 over here, but that means I have to put the 1 and 2 here. So I'm going to try erasing the 4 and the 3. And just switching the orders. Now I can do something like 1, 4, and 2. 1 times 4 is 4. 4 times 2 is 8. And again, I can switch the position of the 4 and 1 later if I need to. Let's keep going. And you could have done this in multiple ways. I'm just showing you what I'm doing. This is the first time I'm looking at this problem. So I'm thinking to myself, 36 has to be like 4 times 9. 4 times 9. So if I get 4 times 9, that would have to be 4 times 3 times 3. Now you'll notice my repeating 4s here. So we talked about how I'd maybe just go back and switch these two. So I have 4 and 1. Okay, so that's 12, and then 12 times 3 is 36. Now I just need to fill this in. 4 numbers that multiply to be 24. And basically what I'm going to do here is think about where I can place the numbers in here. So notice how you have to have a 3 in each of these columns here. I'm missing a 3 here and here. I can't put the 3 here because it's repeating, so therefore the 3 has to go here. Let's see if we see some other numbers that are like that. How about the 2's? 2, 2, 2. We're missing a 2 here. Can't put a 2 there, so 2 has to go here. We're missing a 1. 1, 1, 1, so the 1 has to go there. And of course that one has to be the 4. Let's double check. 4 times 3 is 12. 12 times 2 is 24. All correct, you get 4 points, and then it's wrong if you get 1 point. Question number 8. Graph this. Okay, so we're going to have to graph by multiplicity here. Whatever my answer is, I have a negative. My leading coefficient is negative, so it's going to switch the arrows. Remember, here's the trick. X squared times x squared is a quartic function. Quadratic times a quadratic is a quartic function. The quartic function is an even, and the easiest even we know is x to the squared, so it should look like this. But the leading coefficient negative makes my graph look like that. So that already tells me with the leading coefficient and the degree of the polynomial that my arrows are going to start down and down. Let's zoom out there. Based on this information, I know my graph's going to start down and down. Now, you don't have to make a chart, but I like to organize my information, just like we did on the previous page. I have my zeros, so x plus 6 equals 0. Subtract 6, x equals negative 6. And then over here, you have x minus 1 equals 0. Add 1 to both sides, you get x equals 1. And then I'm going to look at its multiplicity. Like we did on the previous page, the multiplicity is the number above. So x equals 1 corresponds to this binomial, and then it's a power of 2. See if I can zoom in there. Okay, so multiplicity in this case would be a 2 for the 1 and 2 also for the x equals negative 6. And these are both evens, odd evens, so these are going to both kiss off the x-axis. Let's go ahead and draw this. So x equals negative 6, put it over here. X equals 1, right there. And we can label this, so let's label it. You can put a 1 right here, and a negative 6. You can get some more details, right? So, like the previous problem, you can also get a y-intercept to make this super accurate. And you could take the 6's and you can expand it out. Or just realize that -1 squared is 1, 6 squared is 36. That's 36, so -36. And you can do that here, -36 times 1. So based on multiplying the constants and the leading coefficient, we get negative. We're going to have to go through there at -36. Let's try sketching this. So I'm going to start here. We're going to go from left to right. And the first thing I approach going left to right is the pink dot, which is a bounce or kiss. Okay, now this one's not necessarily a bounce. I just have to go through it, and I have to kiss off there. So smooth curves. And in art, you can always just make your lines thicker if you miss it. So looks something like this. How did I grade or award you points? I gave you 4 points. 4 points if it is, you knew that it was a quartic. Quartic, 4th degree, right? Even degree. So the arrows were the same. Your end behavior. So starts down, ends down. Your zeros, those are the dots. And your multiplicity. Multiplicity, that's your kiss and shoot throughs. That's how you got 4 points. If you made one mistake from that box, I'll give you 3.75. 2 mistakes, maybe 3 mistakes, or the other way of thinking about that is 2 correct, and then you got 1 correct. So that's how I'm going to award you guys points on that problem. Question number 9. Draw the polynomial with the following characteristics. And I have these little boxes to help you check it. So even degree, it's going to look, starts down, ends up. Positive a value, okay? This is good, this is good. So it gives me something like this now. So let's put some check marks now. I feel a little bit more confident. We have some more information. 6 x-intercepts. Now it doesn't tell me where to put the x-intercepts. So I'm going to wait a little bit. Now it does tell me absolute maximum at y equals 1. So let's go at y equals 1 here. Let's color code that. That's the yellow line, right? And then a relative minimum. So it's saying the graph could never go higher than this yellow line. And at -4 is some kind of minimum. Okay, so we drew those on the graph. We can eventually sketch it. And then 6 x-intercepts. I don't know. You can put those anywhere you want. You could do them like bounces. So you do something like this. Oh, I didn't go down here. Uh-oh, how do I get down there? You can go below, right? So let's go. What did I do with my eraser? You can go below here. Uh-oh. You see that? I can't because I know those are even, so I'm going to have to draw another 0. Let's see, 1, 2, 3, 4, 5, 6. Okay, that matches. All right, something doesn't look right here. It's saying that the mountain, the highest point in the mountain is a yellow, but we have an even degree polynomial. These are going to go on forever. So there's going to be some taller peaks up here. What does that mean? Not possible to draw. Not possible to draw polynomial function. And don't be surprised by this, because we actually did these in class, right? We actually did problems where you're not able to draw them. So you have to take all your puzzle pieces. We drew a visual, and our visual doesn't match our description because you can't go anything higher than absolute highest peak. Now you're saying these are peaks and these are not, but there could be peaks up here, right? So it might do something like 4 points if you knew not possible, and 3.75 if you drew some of your characteristics correctly. All right, last question. That one's just for your quiz corrections. Write two different cubic functions as a product of functions with the given characteristics. Okay, so it says x equals 4, multiplicity 2, and x equals negative 2. Okay, so I already know the answer is it's going to be a cubic function. And what I'm going to do is I'm going to set these equal to 0. So how do I do that? I'm going to go back the other direction. X minus 4 equals 0. And I have x equals negative 2. So I'm going to add 2 here. And I have x equals plus 2 equals 0. Now these become my binomials. Does that make sense? So I can say f of x equals, and then I go back with my multiplicity. This 2 there goes here. So I have f of x equals x minus 4 squared times x plus 2. And then we talked about if you just kind of double everything in the box, or you can double one of them. How about we double this one? 2x plus 4. We'll call it a different function, g of x. This would work. This would work. Or if you did h of x, let's try a different one. Let's just say you doubled both of them. 2x minus 8 squared. And then this one you have 2x plus 4. And basically what it's saying is that if you set this equal to 0, you'll still get x equals negative 2. Or if you set those equal to 0, you're still going to get x equals 4. But the graph's going to have a little bit more energy. Prove that to you guys. You set x minus 4 squared, and then 2x plus 4. And when I'm about to press graph, I want you to notice that they will go through the same x-intercepts, the same zeros, but the graph just goes higher, higher and lower. So bigger peaks and valleys, but you're still going through the x-intercept. That's the big idea. Whoa, 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 whoa. All right, here we go. Let's a calculator work. Okay, here comes the next one. Goes to the same. That's a little bit skinnier there. Uh-oh, what happened to that one? Let's double check. 2x minus 8, 2x plus 4. There's my mistake. And let's change the window so you can kind of see. That was fine. Okay, first graph goes to the same zeros. Big idea, right? Shoot throughs and bounces, and we're gonna have another shoot through. Goes way high, still has a bounce. So it's the same, it's the cubic functions are different, right? They're looking different, but the big idea is the zeros are still there. All right, you'll get a 3 points if you get 1 correct. And of course 4 points if you get 2 correct, and then some wiggle room for some minor errors in there. 4 multiple choice questions, 5 free response, sorry, out of 4 points, that's 20. And then 20, then your plus name period, that'll be 32. Good luck.
Math.
Say it again.
Our math.